Hello there. Welcome to this lecture. Now that you understand what is simple linear regression and mathematical formulas involved in it, let us write our first Python program which is going to be implementing simple linear regression algorithm, and this we are going to write from scratch. We will write the complete algorithm in our Python program. As a data scientist, you normally don't have to do it because there are made in libraries available. You just have to call that library, and we will do that too. But let us go through this lecture and let us do this on our own so that you understand and appreciate the complexities as well as you will understand a bit of Python. So let's begin. First, heading, of course, write what you're going to do, and then next step you already know. Yes, you are right. Import the libraries. SNP import pandas spd import matplotlib dot py plot as plt and import cbon as sns. Let's write next set of instructions, and the first function we're going to write is finding the coefficients, that b0 and b1, and here is our first function, find coef. We will pass x and y to this function and it will return us coef. N equal to np dot size. This command is going to give us the size of the data set, and next we're going to find the mean value of vector x and y. These are normal NP commands. You already learned this when we were talking about normal NP libraries. So I do not have to deliberate on this again. You already know these things. NP dot mean y. And next we're going to calculate the sxx and sxy. Remember, the b1 is equal to sxy by sxx, and here we are going to calculate sxy and sxx. Sxy, let's say, and that is going to be np dot sum of x into y minus n that is the size here, into mean x into mean y, and likewise sxx is going to be np dot sum of s x and x minus n into mean of x into mean of x. And now it's time to calculate the coefficients. So what is b1? b1 is equal to sxy by sxx, and b0 is going to be equal to mean y minus b1 into mean x. Remember the definition of regression? Go back and check what was the definition of regression and you will understand what we are doing here. Okay, and then this function is going to return us b0 and b1. Very good, we got the coefficient. So next function is going to be plotting the regression line. Plot regression line. Okay, let's write our function to plot the regression line. So we are going to call it plt underscore regression underscore line, and over here we're going to pass x, y and b the array which will have b0 and b1. To plot the line, the regression line, you need set of x values, set of y values, and the coefficients b0 and b1. These are all arrays. These are not individual values. Plt dot scatter. So you're going to plot the scatter plot first, of course. X, y, color, let's say is M. Okay, and then marker, let's say is our favorite O, and then size of the markers, let's say 30. Okay, and then predict y. this is predicted value of y, because on your trend line the y values are predicted values, right? So y predict equals b0, the b coefficients, plus b1 and then b1 and then x. And now it's time to plot the regression line. You got x, you got y predicted values, and you got b0 and b1, your coefficients. Now you can plot the chart. plt dot plot x, y pred, and let's say color is G. And let's print the labels. plt dot x label is, we will call it x, and plt dot y label is, we will call it y. And then show the plot. So plot. For showing plot, you just have to say plt dot show. Very good. We wrote two functions, one to calculate coefficients and other to draw the regression line. We are done. Now we just have to write the main function and call these two. It's very easy. Now we're going to write the main function. Oh, these are subheadings, so I will put two hash here. Okay, and let's say markdown. Very good. And it's time to call the main function. Very good. Let's write the main function. I can't hold my excitement anymore. Okay, main, and we are going to use the same tips dataset. I know you are very excited about it, so let's go on. Let's finish it. Load dataset tips, and then df equals pd dot data frame tip. Let's call it tips. Here tips, and let's print the head, so we will know, right, that we got it right. Okay, next are our observations. X, df. So what's x? Because this is a simple linear regression, we can have only one independent variable. Over here we're going to say total bill, and y is going to be df tip. And next we're going to call our estimate coef function, which is this guy here, find coef. So b equals find coef, and then pass x and y, and then plot regression line. And over here we are going to call our plt regression line function. Copy, paste, and x, y, and we got our b. Now that normal if name equals main Wow, we are done. Let us run it now. And here you go, our regression line. So that's what it takes to create algorithm in Python to have your simple regression line. I know what you are thinking. You must be thinking, but I said you don't have to be Python expert to become data scientist or machine learning professional. Actually, I was right. You do not have to write this algorithm from scratch. These are already written for you. There are Python libraries which are already written, which already have this algorithm built in. You just have to call that library. And I will take you through one such library. Actually, you already saw that library when we were talking about Seaborn. There are various such libraries, but let's look at this one. This is my favorite. This is for simple linear regression, and it is provided by Seaborn. So let's say simple linear regression using Seaborn library. And over here you just have to write one command. You need to write just a simple command. And let's take the same data set here. Okay, this time let's call it df1, and the simple command to do all these things is this: sns.lm plot x equal to total bill and y equal to tip and data equal to df1. Just this one line command and you will get the same graph. Here you go. Exact same linear regression line, the simple line, but just one command. And that is the beauty of built-in Python library. During this course, wherever possible, we are going to use built-in already available Python libraries for you. And that's it. That's the end of this lecture. Next lecture, we are going to use something you can relate to the real world better than this tips database. And you are going to use simple linear regression on that real world example, real world data set. And after that, we are going to move on to different algorithms and play around with different Python libraries. Awesome. I will see you in next lecture.